Hi guys, today we're going to be looking at sketching parabolas with transformations. So the previous lesson we talked about plotting parabolas and seeing what properties it has and what I guess numbers and variables affect the graphs themselves. This is sort of following on from that. Difference is we're using the information we had from the last lesson to inform for us to make predictions about where the parabola will be on the Cartesian plane. So, things we're going to be looking at. As we said, with ax squared, a greater than 0, the parabola greater than 0, the parabola is upright, which is just a normal one. A less than 0 parabola, oops, is inverted. So for y equals x minus h squared, h is a translation horizontally. What I mean by translation is that it moves. Translation is another way for move. And it's always in relation to the general graph y equals x squared. So it's saying what happens to the graph from x squared. So does it get wider or thinner? We call that dilation. And does it translate up or down, left or right? So for example with this, if I have y equals x minus 3 squared, then it's a y equals x squared graph translated 3 units right, because it's positive 3. So it would look like this. So here's 3. It will go through, let x equal 0, y would be equal 9. So the y-intercept would be 9. And it would look like, roughly like that. So it's just the same x squared graph, just moved to the right 3 units. Obviously if it was x plus 3, it'd go back the other direction. Oops, I might show you this so that you can see it. Yeah, so that there is the y equals x minus 3 all squared. So as you can see, here's my y equals x squared graph that I've lightly drawn there. It's just the same graph moved 3 units to the right. And if it was x plus 3, that graph would move to here and it would be at minus 3. Alright. As for y equals x squared plus h, oh sorry, we'll call it k. We'll call it k. K translates vertically. So k translates vertically. So in other words, it moves the graph up and down, up and down. So if I have y equals x squared plus 5, here's my original graph. So and it's moving up 5. So it's just the same graph that's moved up 5 units. Now, what we should start seeing is that we're actually able to figure out where the turning point is by looking at these numbers. This tells us that the turning point will be up 5 from the origin. If we go back to this one, we know this will be 3 to the right of the origin. So what happens if we put both in the same? Well, we call that. So for example, what if we had, oops, we might show this, x minus h squared plus k, with an a at the front. A is the dilation factor. We call this turning point form. Oops, if I knew how to spell. So this is called turning point form. Let me just move this. That is turning point form. Now, the reason why it's called turning point form is because h and k is the turning point. H and K are the turning points. H and K is the turning point. So the value of H and the value of K tell me where the turning point is. And the axis of symmetry is x equals h. Axis of symmetry is x equals h, because that's where the turning point will be, and that's where, if I cut through, it will be mirrored on each side. Alright, going to do an example now. We'll do I might do a difficult one just so that we can see what it's about, and so you can realize just how, how important the factorizing stuff becomes. So we're going to get x squared plus 4x plus 1. So we're going to graph this. Y equals 4x, x squared plus 4x plus 1. If we look at the turning point form closely, if we look at this closely, this looks exactly the same as the first step of completing the square. We've squared the part here and we've got something left over at the end. So by doing the steps of completing the square, we're actually able to make the graph that I've shown, the rule that I've shown in to turning point form, and hence we're able to solve it. So let's have a look at this. Remember, when we're completing the square, we grab this number, we halve it, and we square it. So half of 4 is 2. 2 squared is 4. So I'm going to be adding and subtracting 4 to this equation. Now, this will look like x squared plus 4x plus 4 will be the squared part. We've got plus 1 minus 4. So this will turn into x plus 2 all squared, and I'm going to simplify numbers into minus 3. As you can see, a nice, neat completing the square. Now, if I was to, I'm going to go back to my general rule of completing the square, which is here and here. if we can see, they're in the same form. The plus and minus doesn't really matter. It's not an issue. It just tells me that k will be a negative number instead of a positive. So I'm going to label what h is equal to and what k is equal to. Now, if it's minus h and this is plus 2, that tells me that h is negative 2. And we know that k will be negative 3. So that means the turning point, or just 2TP for short, is negative 2, negative 3. Negative 2, negative 3, because it's hk. So I'm going to graph this. Oops, wrong way. Okay. So here's my little graph. My turning point, so that's my starting point. Negative 2, negative 3 is here. We find our y-intercept. So we find our y-intercept by letting x equal 0. Or if we go back to the start, with most graphs, nearly all graphs, the y-intercept is always the constant expanded. So my y-intercept is going to be this number at 1. So this graph is going to pass through the y-axis at positive 1. Oops. I know it's a little bit hard to see. So positive 1 will be here. What's with the... Okay, there we go. Positive 1 will be here. There's negative 3, 2. This is the turning point. That's there. I'm going to come through here. And I'm going to come through here. Now, if I wanted to, I could find the x-intercepts. I find the x-intercepts by letting y equal 0. If I let y equal 0, it becomes a solving quadratic equation. But it's not necessary at this point in time. Now, in this exercise, you will not have to. Let me check. In this exercise, you actually won't have to factorize it. It will give you turning point form, or it will give you a translation formula, like a certain translation. So it might only translate up or down, might only translate left or right, or it might do both at the same time. So essentially this is, if I look at this graph here, here's my this is my x squared graph. I know it's not well drawn, but you get the gist. Basically this graph has been moved down 3 and across 2. So if I was to talk about what's happened to the graph, it's been translated down 3 units and translated to the left 2 units. And the dilation is factor 1 because A is equal to 1. There is no number at the front here. Alright, so to sum up, turning point form is used to help sketch the graph, the parabolas. There are two values there are two forms in which the graph changes. So x minus h translates horizontally when it's in a squared brackets. When you have a number outside, or without brackets, it translates vertically, so up and down. And when you have both, a combination of both, so an x minus something squared plus something on the outside, it's going to translate left and right and up and down. And it should look like this. So the 3 types of graphs you'll deal with are x squared plus 3, for example, y equals x minus 2 squared, and y equals x minus 2 squared plus 3. So they're the three types of graphs we're going to be dealing with in this exercise. Also, I want you to think about what happens if I make these negative. What happens if there is a negative on the outside of those brackets? It's very important to know because it's going to change the graph dramatically. And I would suggest you graph those and actually see what happens.